let's go ahead and get into this. So we're at 29 see, now it's saying 29.48. 29.48 inches of mercury. So we're going to look at our 30-inch of mercury chart, where you can see it there, it says 30. And then we're going to look at our 29-inch of mercury chart. And the reason why is because we are at an altitude that, or a barometric pressure that's in between those two zones. So hypothetically, let's just say that we are going to shoot 1,300 yards even. Alright, so our 30-inch mercury zone will tell us that we need to come up 19.9 mils, and that's at 30 inches of Hg. And then for 29 inches of Hg, we need to come up 18.7. So that's over a whole mil of a difference there from 30 inches to 29 inches. So now we need to determine our real correction for where we're at. And we are 0.48 inches of mercury in between those two zones. So what we're going to do, and this is actually where we're going to work on fixing some of the math and doing it the right way, instead of the way I was doing it, which basically I've been telling you guys the wrong way to do things, and it's not going to be the most accurate. So like I said, ever evolving and ever improving system here. So we're going to take 19.9, we're going to subtract 18.7, and then we're going to get, what is that, 1.2? And then we need to take 1.2 and we need to multiply it by 0.48. So 1.2. Sorry guys, I know it's getting kind of dark out here, and the camera's not going to pick up most everything. So multiply 1.2 times 0.48, and we're going to get 0.576. Alright, now I was, in previous settings, I was actually saying to take this number and add it to the low number here. Okay, but that is actually incorrect. It will be much closer to reality if we take the high number and we actually subtract this. And the reason why, and I determined the reason why this is the way to do it, is because of the parabolic arc of the bullet flight, its flight path, its trajectory, is that your ascending leg is longer and not as steep as your descending leg. So the further you get out there towards the target, the more the bullet's dropping over a shorter distance. Okay, so, and I actually, when I reworked the math on Garen's drop charts, and I kind of reworked his drop charts too, but when I did the math, the one way of adding it to the low number, it actually told me that the elevation value was actually less than it should be. What we observed like 36 minutes of angle is what he needed to come up, and or is what he ended up coming up to. And what the math was telling me was that he needed to come up like 34 or 33 minutes of angle. But when I reworked it and I actually used the high number and subtracted the value that math problem was giving me, it actually gave me 36.1 minutes of angle is what he needed to come up at. So it was like almost dead on accuracy wise as far as that math goes. So I will explain that whole deal in another video, like I said. So I'm going to get back to this. So now we're going to take 19